Timing can make all of the difference when it comes to whether an animation looks good. Today, I'm going to show you 4 different types of timings and how you can do them in Remotion. The simplest type of timing is the linear timing. You simply change a property value over time, and the speed at which you do it stays constant. The linear timing can, for example, be a good choice if you have, for example, a sky and you want to animate some clouds or planes flying by. These objects usually have constant speed, so making them animate with a linear timing makes them look natural. To create a linear timing in Remotion, you can use the interpolate function. Here we say that the interpolation is based on the current time, which is the frame variable. And we say that if the frame is 0, which is at the beginning of the video, that there is a translation of minus 150 pixels applied to this square, which by default is in the center. And when the frame is 60, which is at the 2-second mark, because our video has 30 frames per second, then the object has a translation of 150 pixels applied to it. And for all the frames in between 0 and 60, we calculate the appropriate translation. With these 2 parameters, I have disabled extrapolation, which means that when the frame goes over 60, then the square stays in the same place. We can also remove this code, and then the animation continues after frame 60. You can also pass an easing function to interpolate. Here I have passed an in and out ease, and what it does is it makes the start and the end of the animation a bit more subtle, and it doesn't just start and stop immediately. Rather, it slows down a bit at the end to make it more natural. Next, let's look at the spring animation. The spring animation is super cool because it is actually based on physics, so it looks super natural. This is how I implemented this timing in Remotion. I used the built-in spring function, passed in the current time and the frame rate, and said that the starting point is minus 150 pixels and the endpoint is 150 pixels, and then I used this as the translation. Now, interestingly, you don't have to pass in a duration because the spring animation is just done when, based on the physics, it doesn't move anymore. You can, however, if you like, pass in a duration in Remotion, and then whatever the natural duration of the spring is, it is being stretched to the duration that you want. You can customize some physical properties of the spring and change the animation curve with that. There is damping, mass, and stiffness, and this is a bit unintuitive. You should just play around with them. But to make it a bit easier, we have actually created a helper tool that I am happy to announce at this point. It's called springs.remotion.dev. You can go to this website and tweak the parameters. You can see live what it does to them. And yeah, it's really cool. So you can, for example, increase the mass and create this really heavy spring, and with that, a pretty interesting animation curve. You can even click on code and then copy the code that is needed for this spring in Remotion, paste it into your project, and as you can see, this exact timing is now applied to the blue square. Let's now talk about the timing that was used in this intro scene for GitHub Unwrapped. So it starts off really slow, but then kind of like exponentially accelerates like a real rocket. I call this time remapping, and for this I have written this helper function. Imagine if in this function we would pass in 2, then we could pass in the current time and we would get twice the current time. So we speed up the video by 2x. We could also pass in 0.5x to slow down the video. But what we do instead is we allow you to pass in a function, and this function can again be a linear interpolation. And with that, this time we do not interpolate the time, but we interpolate the speed. So we can make something go faster over time. Now here is how I use this function. I take the current time, pass it to remap speed, and also pass in a function. Now in here we have a linear interpolation like before, but I actually want the acceleration to be exponential. So I use the calculated value as the exponent of 10. To illustrate what I am trying to do here, I have plotted this formula, and as you can see, it really draws as a hockey stick, exponential growth, the dream of every startup founder. And if you apply this as the translation, this is how it looks like. For the final type of timing, let's approximate an object flying towards the camera. My current distance to the camera is about 1.5 meters. Let's say I am right now at my natural scale. Let's say it's 1. Now, if I were super close to the camera or even inside the camera, past the camera, my scale would be infinite, right? Because I would be so big, the camera would have no way to capture me. So let's try to imagine this and apply it to our animation. So here is what I've done. I've taken the current time and I have said that I have an animation that goes from frame 0 to 60. Then at the start of the animation, I am saying that my distance is 1, could be 1 meter, but actually it's unit less. And at the end of the animation, my distance is very, very, very close to the camera. I cannot actually put 0 because then we would have a division by 0. So I put a very small number instead. And then the scale I define by dividing 1 by the distance. So if the distance is 1, then the scale is 1. If the distance is 0, then the scale is infinity. And this also is a type of exponential growth. So this is how we can make an item appear to be approaching the camera. In this case, we have made it that the item appears to be coming closer to the camera at constant speed because we have used a linear interpolation as described in the beginning of the video. Now, if we wanted to, we could also make it that the item appears to be accelerating and come even faster closer to the camera. As you can see, you have so many options. You're in full control of the math, which is an advantage, but also a responsibility. But nonetheless, I recommend you to try out these different animations. Try to think of which type of timing works for which situation, and practice, 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 and your animations will look better and better over time. I will also link the repository that I have been playing with down in the comments. I hope this was helpful and see you in the next video.